Next, we have Dr. Charles Nduka. Surgeon Dr. Nduka is specialized in facial muscle disorders and found MTech Lab to provide comprehensive digital biomarkers for passive monitoring of emotional responses, dietary behaviors, and health. Let's welcome him.
Thank you. Thanks, Kristin, for the invitation. It's my first time here at the Buck Institute, beautiful place and a very welcoming group. So I'm probably unique here in being a plastic surgeon at a longevity conference, and I think I've got a slightly unique perspective on things, which I'll hopefully explain. I'm going to talk a bit about my role and how I got here, about measuring what matters. That's the strapline of my company, MTech Labs, which I founded some years ago. I still practice part-time. I want to talk about the issues with current measurement techniques, how we measure, and what our technology could do to perhaps help that. This book, I'll start with why, was quite inspirational for me, the why of what we're doing. And everyone here is about trying to help people live better lives. But what do we mean by better? We mean quality. People want to be happier. People don't want to have a really long life if it's going to be full of pain and distress. They'd rather have a longer health span, but maybe even more than that, a longer Joyspan. So in my work as a plastic surgeon, I specialize in facial paralysis. This lady had a tumor that caused damage to her facial nerve, and you can transfer muscles and nerves to improve the quality of life. Aesthetic surgery, same sort of thing. Patients want to move towards this middle ground of being happier, better. But there's a large body of evidence that shows that people who are happier tend to live longer. People with cancer who have a negative affect tend to respond not so well to treatments. People who have depression plus one other major illness tend to reduce their life expectancy by up to 20 years. And so we know this. There's also evidence from the large-scale studies, the Harvard study, which you all know about, how it's so important to have, apart from, obviously, usual things, exercise, don't smoke, etc., but the quality of your relationships and your social interactions really count. And multiple cross-sectional longitudinal studies show that there are changes across life in terms of this dip in subjective well-being that happens at a certain point before there's a rise. And this has been replicated numerous times. But most past studies have been looking at subjective measures. You ask people questions using a questionnaire, and we know that that isn't right. Obviously, we've moved a bit beyond this model of the psychiatrist's couch, asking people questions about how they feel. We're a bit more sophisticated, but we know that there are many issues around questionnaires. There's mood-dependent recall, the subjectivity, maybe not disclosing things to the practitioner. There's a lack of any sort of reference point. And if you just crashed your car on your way to your clinic, of course it's going to affect how you feel and how you respond to questions about this. And every single person here is ultimately trying to help people feel better. And so we have this battery of many assessment tools that people use across neuroscience, psychology, quality of life measures in gastrointestinal research, across musculoskeletal, everything really. But it becomes really, really difficult to really understand what's going on. If you're measuring this thing that is so subjective and so error-prone, either due to bias or memory recall, we know that Kahneman talked about the peak end effect, which basically means that you'll remember things that happened most recently, or that was most intense, but not necessarily the whole thing. Then we end up confusing the causes of things, correlation or causation. If you have somebody who has an issue that happens and you didn't know the sequence of events, what caused what, where do we go from there? Was it the emotional thing that caused the person to comfort eat, that caused them to gain weight? Or was it something else? Was it the availability of foods? Was it the location? Was it the people around them? Was it the toxic people, as mentioned in an earlier talk? If we don't have the measurement tools, we're running blind. And so I think that any doctor, researcher, clinician, company that confuses correlation with causation isn't really going to help people. And we can think about this in terms of a timeline. Each dot here represents a day of a year. And if we think about the color coding in terms of yellow, pink, and red, in terms of severity of symptoms, then of course symptoms will fluctuate over time. And if we think about the blue dots as being visits to the clinic or to the researcher, we have this issue where if you're just asking people questions, and because people's memory is incomplete, then you'll end up capturing only a thin slice of information that may miss huge chunks of data. And this is a problem. People have tried to innovate here using devices such as the smartphone, and even Apple, with their new health kit, they have introduced this subjective self-report using PHQ-9, asking questions, how you feel, how do you feel now, how do you feel now? It gets pretty boring, pretty tired after a while of doing that. I don't know whether any of you have ever tried these tools. And patients fatigue, they'll end up just asking the same thing because it's just bugging them the whole time. There's also a big problem because if you're just scheduling appointments, you're looking at a very thin slice of a person's experience. You could be measuring and seeing no difference. And for those who are developing treatments, you could find that you need a huge sample size because you're not seeing a difference. But actually, what was really going on was there's a massive variation over time. And so for those developing treatments, we need better tools to get better treatments. Because what we see ultimately depends on what you look for. We've tried to invent tools to measure. Obviously, the thermometer took 100 years to get adoption because people thought, I'm good enough to measure subjectively with my hand on the person's forehead. But even that one thing of measuring temperature allowed us to identify different kinds of infection, which is the swing in temperature you get with certain pyrexias, the high temperature you get with certain cancers, hypothermia, ovulation, all range of things. That simple thing of measurement. We now have tools to measure things such as heart rate, measuring blood pressure, measuring body temperature, like identifying disease, and glucose. Because by measuring, you now become predictive. And that's what we kind of lack at the moment. But we don't really have a tool to measure objectively emotional responses. So I'm in the post-lunch session, so I'm going to have to make it a bit more interactive. Here's a little quiz for you guys. Who's winning? Who's happier, A or B? Hands up for A. Hands up for B. Yeah, you've got a little cue there. That's right. And how did you guess? You went psychic. Yeah, it was written all over his face. This image is from a paper that was shown earlier on from the plastic reconstructive surgery. This is a twin study, a very interesting paper from 2009, looking at identical twins who were in different contexts. And I think it didn't take too much to recognize who had the more positive or more negative experience. Different kinds of stress. In this case, this was sun exposure stress, but again, written all over the face. And we often measure biomarkers as snapshot of blood assays or snapshots of sort of physical signs in the tissues or in a cell, but they're also on the surface as well. Every wrinkle, every age spot represents a stress of some sort, a physical stress, environmental stress, a chemical stress, but which is measurable. And so these objects are actually events, as Roberto Carlo Rovelli said. Divorce. These things are toxic, as are toxic friends. They cause stress, as you know, hypothalamic pituitary axis. These cause effects on your outcomes that could also influence your research as well. And so what are you missing in your research if you're not measuring these things? Here we go, another quiz. We're looking at smiles now. A, B, C, D. Which smile is the genuine smile? A, B, C, D. This is a bit of a trick question. This is a study about pain. So this is every single person here. And what's interesting about pain responses is that it's not in the smile you look for this information. It's all in the eyes. And we know this intuitively because in research, we use faces for these pain scores. So in my work as a plastic surgeon, we were developing tools to understand patients' expressions. Facial EMG has been used for many years in psychology and neuroscience to objectively measure emotional responses, the so-called emotional valence, by looking at the balance between the corrugator muscle and zygomaticus muscle. And at the beginning of the company, we just took what was known to be gold standard and adopted it for use in the lab and later on in the home by incorporating it into a VR headset. So we could change the emotional experience of the person based on what they saw and what they heard, and then simultaneously measure the facial expression responses and heart rate responses using EMG, and map that to the dimensional model, which is the model used in a lot of research to understand emotional responses. So this isn't a categorical way we say happy, sad, fear, anger, disgust. This is more dimensional. So high arousal, i.e. Increase in your physiological responses, heart rate, respiratory rate, etc., sweat response, and then valence. That's the important bit. Is something positive or negative. And it's an important distinction here because people talk about stress, but they don't distinguish between positive stress and negative stress. Obviously, positive stress is what we want, hormesis. We want to experience that run, that cold shower, that intermittent fasting. That stress is good for us. We want to avoid negative stress. So our technology is called facial optomyography. And rather than using electrodes, we have optical sensors, non-contact, that measure the very fine movements of the facial muscles as they change the texture of the skin. This has been in development for quite a few years now, and we're currently still doing it as a research project, and we plan to launch our first version for partners next year. We're sampling at 2,000 times a second, and then streaming this via Bluetooth to a device. If you're interested, you can have a demo later on. So the version we have currently is shown here. You'll see that in the video in a second. Then next year, we're going to launch a stripped-down version, which is principally for dietary monitoring, which will be available to partners who are interested in understanding their customers. Because any clinician, longevity doctor, or similar, you're only really getting a thin slice of information about how the person's doing, and this helps to fill in the gap, be it a dietary assessment or more. I'm fortunate enough to have a stellar team. Steen Strand is our CEO. He's based in Los Angeles. He's previously was the head of hardware at Snap, and so he's launched previously very complex smart glasses. Hristijan Grajewski is a professor of AI at University in Macedonia, in Skopje. It's got a fantastic team of 11 data scientists, and we have some amazing partners and investors. Lord Darzi, previous government health minister and surgeon, who was our first investor, and others. So these are the glasses as they are now. They stream data in real time, 50 hertz, and tracking both expressions, head motions, and then using AI to interpret bodily movements as well. It's comprised of the glasses with the sensors incorporated, the supervision app, which we can use for research in a lab to monitor what people are doing, apply annotations if you need to, and obviously the cloud-based analytics. And this gives us a number of streams of data. You have the expressions and dietary behavior. So one of our developers accidentally discovered that we could measure eating because he was trying to debug the facial stuff whilst having breakfast and could see these movements over time, and every chew was being recorded. And it's that led us to realize that, wow, we have something here that could be really quite transformative for understanding dietary health. Physical activity. Of course, you can use a Fitbit or an Apple Watch, but what you get from being on the head is that you get much more information, not only about posture, about sitting versus standing, but also things such as gait. So when you're walking with a limp, I know that a lot of you researchers doing studies with animals are using the movements as an indication of pain. But of course, you do the same with people. If a person's got a limp and a limp improves, you can measure that objectively, as well as obviously measuring the facial expressions. And then obviously measuring real-world responses rather than just relying on what people say. We've done a lot of validation work around activities of daily life, which allows us to measure people in the home, in the real world, and get really what's going on rather than relying on self-reports. And so we can measure, at the moment, a number of categories of movement in terms of lying down, standing, sitting, et cetera, et cetera. And you don't need to have the person wearing the glasses all the time, although we have a long-term belief that just as at least 50% of people in the audience are doing, that glasses will be the next interaction platform beyond the smartphone. And certainly that's the belief of companies like Apple, and Meta, and Google, and others. Gait's a very interesting one, obviously with posture as well. Again, when somebody's getting older, you see that with a loss of vigor, both in terms of their posture when they're walking, but also just their things like their stride length and the step length. There are certain conditions as well that have specific changes, such as Parkinson's disease, where you'll see a classic shuffling gait where the stride length is decreased. Patients often have a forward-looking center of gravity, and often that causes a fall as well. That change in center of gravity, so it's in front of the person. And we use computer vision to help validate and annotate our data sets. And so we have this really rather unique data from this one device, 4 categories of data: expressions and emotions, which is comparable to EMG, but obviously without skin contact. And unlike cameras, it can work at night time. There's no issues around point of view and no privacy issues for third parties who happen to be around. We have the ability to measure mood. We published a study last August on depression with Professor James Stone at Sussex University, demonstrated that we could detect differences between depressed versus non-depressed people based on how they respond to experiences. Dietary behavior, obviously a huge issue. Who here has tried using a dietary monitoring app like MyFitnessPal or Noom or anything else? Who managed to do it successfully for more than a week? Yeah, it's not very easy, is it? I mean, half the time you just forget, whereas our technology will measure that you're eating automatically, remind you, and if you want it to, you can take a picture automatically of your food and then analyze the dietary content and its macronutrients. We're using AI to analyze the food content, and it's getting better, but we can already be within 20% in terms of energy, calorie estimations, etc. Some people eat a lot because they're just distracted. There's a very funny psychology research where they have people in a movie cinema and they're watching a film and they're given this popcorn, but they don't know there's a little tube underneath there and popcorn's being refilled, and they're watching the film and they're just eating and eating and eating. A lot of people do that. You eat while you're on your phone, you eat while you're doom scrolling, on your laptop, whatever else, and that's one of the causes of people overeating, just unconsciously. Another big factor is the speed of eating. If your parents were overweight, they were probably fast eaters. And because we learn from our parents or from those around us, we often take on those habits of being a fast eater. And if your metabolism isn't able to burn those calories, then you will ingest more calories than you intend, because there's that 20-minute delay or so between ingestion and a signal from the brain to say stop. And this is a big factor. Dietitians, they instruct people to try and eat more mindfully, to slow down. Our glasses can give you real-time feedback on your eating rate, and hopefully guide you towards the better behaviors to avoid gut symptoms as well. And as I say, things such as intolerances, trying to understand which foods are causing issues, FODMAP, IBS, etc., because of the strong connection between mood, gut symptoms, and what you're eating. So we see this as a really powerful research tool, assessment tool, and hopefully in future, a platform to allow others to develop interventions as well. This is a demo of the dietary stuff. So at the moment, we're doing hand-triggered because of privacy concerns, taking a picture of the food. It takes, at the moment, it's about 10 seconds, but that's in the iterations coming next year. It's going to be about 5 seconds to go from device to platform, and then giving estimates of the calorie content, macro and micronutrients, and then being able to look precisely at eating behaviors. And so people have a wide variety of eating rates, and sometimes it's cultural, sometimes because you're in a rush, sometimes it's because of just the context of where you are, if people are eating on the go. But being able to measure this in a way that is intuitive, non-contact. Okay, the glasses are at the moment a little bit bulky, but they will be more normal-looking within the next year or so. We see this as being quite an important way of guiding healthy behaviors. Our pipeline allows us to gather a huge volume of data around detailed eating metrics in terms of how you're eating and what you're eating. And by providing people with a feedback around their previous day's consumption, it can hopefully help guide people towards better behavior. The research shows that very few people can measure, most people can remember what they ate the previous day, but very few people can remember what they ate, say, 2 days ago. I don't know whether anyone can remember what you had for breakfast, say, 3 days ago, but you probably can't. That's what the research tells us. And so we hope to take research from being something that was very difficult to do or very subjective or very complex and lab-based with lots of different devices to having a single device that enables us to have real-time objective data that can work both in the home and in the real world, that can give personalized information and also guide research to be more accurate, reduce sample sizes, avoid variability, and avoid the failures that shouldn't have happened. At the start of this talk, I talked about my role in trying to help patients with facial issues, but it goes much larger than that. I'm really looking forward to discussing with those who are interested around potential partnerships so we can all drive towards this goal of improved health span. Thank you very much.
Hi, real quick. I'm curious what, if any, data you get if people are simply sleeping with these glasses on.
Yeah, so that's a really good point. So you get a combination of different measures. So the IMU is tracking movement, head movements, and anyone who's alive is moving, even if it's a tiny amount. And because it's a 9-axis IMU, you get movements around this. You get respiratory movements, which are there, which are really, really interesting. And then obviously arousal levels as well. There is eye blink movement that we can also detect. We're not indexing that at the moment because it's just yet another data stream that we're having to focus on, but that's also there. So obviously not many people sleep with glasses on unless you're in a chair. But in terms of that sleep question, what you do in the daytime has a massive role to play on the night you'll have subsequently. One of the things I found difficult about sleep trackers is that in the morning, telling me that I had 5 hours sleep wasn't really helpful because I couldn't act on that. But in the daytime, knowing that what I'd eating late, that difficult thing I did just before bedtime, that's going to impact on my sleep, I can act on that.
Great, so it's an excellent presentation. What about the practicality? Do you actually have to build new glasses, or can you just put your app on some of the existing efforts? If you play it forward, these glasses have had difficulty getting into the market. How are we going to get it to local? Because it's such a great application.
Yeah, it's a really good point. I mean, we did look at this, could we just add something to existing glasses? One of the problems is that we're always trying to deal with this issue around comfort, battery, and acceptability in terms of look and feel. One of the things that dealing with patients that nobody, be they facial paralysis or depression or obesity, they don't want to be even further outside of what's considered normal. And this is why we believe the technology will have to look like normal glasses for it to be adopted. And that's why we're starting off with the dietary use case, because they will look normal. The sensors that go in the front are a bit bigger right now, and so we're going to be raising investment to get those miniaturized so that they'll fit into something that looks more normal. But I strongly believe that they need to look as normal as possible for people to accept them.
Yes, thank you for the great talk. I guess you feel like the only plastic surgeon. I feel like I'm the only dermatologist. But I have to ask this question. For people that do Botox, did that have an effect on your reading and data? Thank you.
Yeah, that's a two-part question in a way, because obviously one of the potential use cases for this is for facial biofeedback. So for those who don't know, there was research published back in 1988 by Strack, who found that people who expressed certain emotions amplified them. So if you could trick people into furrowing their eyebrows, they tend to interpret things more negatively. And likewise, if you can get people to activate the zygomatic muscles, they tend to interpret things that are ambiguous more positively. And that's been replicated now in a big, wide-scale, randomized controlled trial. I find in my practice that Botox does actually cause an improvement in people's mood, apart from the direct improvements in terms of things like tension, headache, and migraines. Each person expresses individually. And one of the problems that most researchers had in the past is a one-size-fits-all approach and assuming everyone's the same. Of course they're not. And so because the glasses are for longitudinal data collection, you develop a personalized model for that person. So just in the same way that you would know somebody that you know who, for example, uses Botox, you'd know when they're smiling in a genuine way versus not. And so too, there's a self-calibration process.
Yeah, I think it's a good follow-up on that question, because I find your work fascinating, and especially the aspect of mood monitoring. And I was wondering, because exactly like smiling or frowning are also voluntary activity. Yes. So are there other traits that are non-voluntary that you can monitor? And partially you answered this question, but I would like to hear a bit more about that.
It's a very good point. So what's interesting about the facial nerve is that, and the relationship with the brain, is that there are two modes of communication. You have the voluntary pathway, and you have the automatic pathway. So we evolved the voluntary pathway to enable us to speak, to manipulate food, et cetera, but the muscles around the upper part of your brow are largely under involuntary function, and the pattern of movement is different. So anyone here can raise eyebrows independently. Who put your hand up if you can do it independently. So both of them, like one and the other. It's very difficult. So facial muscles don't have spindles. So other muscles around the body have spindles that give proprioception, give feedback. So I can close my eyes and touch my fingers in midair very easily, but individually moving muscles is very difficult. And so we can distinguish spontaneous versus voluntary movements by the pattern of movements. Thank you.